Located 150 kilometres northwest of Brisbane in the Bunya Mountains is Mount Mowbullan and home to the Brisbane VHF Group's 2-metre beacon VK4RTT. At over 1,100 metres above sea level, Mount Mowbullan offers a great takeoff to provide VHF enthusiasts with a useful propagation monitoring beacon. RTT has been serving the VHF community well and for over 30 years. With age catching up, a replacement was becoming necessary, and on January 20, 2013, a new VK4RTT hit the airwaves. The new beacon uses a rugged Philips FM828. To improve reliability, a lot of the internals were removed, leaving only the exciter and PA units. The old power supply board was replaced with modern regulators. A controller board using a 20-pin PICAXE microcontroller was developed by Adam, VK4GHZ. This generates the CW and takes care of all the system housekeeping. Analog to digital converters monitor various parameters, such as the system volts. A thermistor measures power amplifier heatsink temperature and will throttle RF output down as well as increase the fan speed, if required. A directional coupler built by Jeff, VK4KJJ, monitors reflected power. Any alarm conditions will change the behaviour of the transmitter to attempt to get it back to nominal values. Alarm conditions are also reported as a part of the CW sequence if and when they arise. VK4RTT operates on a carrier frequency of 144.440 MHz. To hear the beat note, tune your receiver to this frequency in CW mode. Let's take a listen. It sends DE, followed by VK4RTT, and then its 6-character grid square, QG53TC. Then, 15 seconds of key-down carrier. The beacon features alternate power output levels. One cycle will be at 30 watts output and the next at 5 watts, as you can see on the S-meter here. On the low power cycle, it also sends low power in the sequence to advise of this, followed by the 15 seconds of key down, then it repeats. In USB mode, tune down 700 Hz or so to hear the beat note. If you hear this beacon, spot it on VK Logger. This allows everybody to look at historical spots for analysis and to map out the paths. For a behind-the-scenes look at the installation, we join Doug, VK4OE, assisted by Mike, VK4XT, as Peter, VK4EA reports.
Okay, here we are at Mount Mowbullan. So, and this is the tower, base of the tower, and that's the little hut that the beacon's sitting in. And going up the tower, we should be able to see the cross dipoles right at the top, and that's the beacon antenna. So here we are at VK4RTT adjusting the frequency of the new beacon.
Frequency moves as we just change the lead, which is a problem for getting it right on frequency.
Yeah, so
what's holding it on frequency? A phase lock lead or crystal? Or
no, just a crystal.
Put your finger on the crystal if you can get to it.
It's on the other side. I've got to take the screws out of the board.
But how can it, if it's on the other side, change the frequency?
Because the printed circuit, all the stuff's still on this side of the board.
Okay. It does warble, doesn't it?
Oh, here we go.
Ooh. Can you play a piano as well, Doug?
It's very tuneful.
Alright.
So we get it.
Sorry, my hand's in the way.
There you are.
What breed of radio is that?
It's an FM828. It's heavily modified.
I've got a pile out in the cupboard somewhere.
No, there's not much of it left. Adam's stripped quite a bit off, and it's just the exciter board and the PA essentially.
Yeah, well.
This is going to have to be a bit of a fudge factor thing.
You know, put the lid down and
look.
You need a plastic cover.
adjusting tools in here.
Yeah, 828 are meant to be SSB transmitters. We're accurate enough to stay on within cycles.
That sounds like it's zero beat now.
Yeah, but what about when we put it all back?
Yeah, it's,
It's going the other way.
But has it gone the other way? Which way have I got to do it?
okay, so there's no audio at the moment because Doug's monitoring with the headphones to try and get it on frequency.
Oh, lovely.
Spot on.
That's
Can we hear it now?
got to be 50 hertz.
Okay, I'm just going to pull the headphones, and that sounds like it's zero beated. Lovely. All right, don't touch it. We all happy?
Yeah. We'll see what Adam thinks.
We're checking the filter, and this is the return loss.
This is return loss looking into that. So that records. That's the low power one. So it's still got that about 16 dB return loss. So that's quite adequate.
So the cavity didn't upset the matching.
Yeah, so that's proven the cavity is all 100%. We've got mentioned about 1 dB loss across the filter. So yeah, we're happy.